Welcome to MSN Digit Max. I am K. Elizabeth, Assistant Professor, Department of Mathematics, Madurai Sivahasi Nadas, Pioneer Meenakshi Women's College, Puvandi. This is the learning resource for Differential Equation, Unit 1 of Module 1. I am going to cover the topics: definition of differential equations, ordinary differential equation, order and degree of the differential equation, methods of solving differential equations of the first order and first degree by using variable separable method. Let us start with the definition of differential equation. A differential equation is an equation which involves an independent variable x, dependent variable y, and differential of the dependent variable y with respect to independent variable x. For example, dy by dx plus 3 equal to 0. In this example, it involves an independent variable x and dependent variable y, and also the differential coefficient dy by dx. So, this is an example for differential equation. Next, we are going to see types of differential equations. Differential equations are of two types: ordinary differential equation and partial differential equation. Next, let us see the definition of ordinary differential equation. Ordinary differential equation is an equation which involves the differential coefficient with respect to a single independent variable. Example of ordinary differential equation: dy by dx equal to tan x. Here y is a dependent variable and x is an independent variable. This equation involves differential coefficient dy by dx. So, this is an example for ordinary differential equation. Example 2. D square y by dx square minus 3 into dy by dx plus 2y equal to 0. This is also a differential equation because it is a differential equation with respect to a single independent variable x. Example 3. dy by dt minus 3x plus 2y equal to e power 2t and dx by dt plus 2x minus 3y equal to t. Here there are two equations. In the first equation has single independent variable t, and also the equation 2 has single independent variable t. So in both the equation there is a independent variable t only. So this is an example for ordinary differential equation. Next, we are going to see partial differential equation. Partial differential equations is an equation which involves at least two or more independent variables and two or more partial differential coefficient with respect to any of them. Next, examples of partial differential equation: x square dou z by dou x plus y square dou z by dou y equal to z square. Clearly, you can see there are two independent variables x and y and two differential coefficient dou z by dou x and dou z by dou y. So, this is an example for partial differential equation. Example 2. Dou square u by dou x square plus dou square u by dou y square equal to 0. In this example also we have two independent variable x and y and two partial derivatives dou u by dou x and dou square u by dou y square exist. So this is partial differential equation. Next, let us see order of the differential equation. The order of the differential equation is the highest different derivative appearing in that equation. For example, dy by dx equal to tan x. In this equation, the highest differential coefficient is dy by dx. So, the order of the equation is 1. Example 2. D square y by dx square plus 3 into dy by dx plus 2y equal to 0. In this example also the highest differential coefficient is 2. So, the order is 2. Next, we are going to see degree of a differential equation. The degree of a differential equation is the power of the highest differential coefficient which is found in the equation after it is cleared of radicals and fractions. Let us see some examples. Example 1. D square y by dx square the whole cube plus dy by dx the whole square plus y equal to 0. Here the highest differential coefficient is d square y by dx square and the power of the differential coefficient is 3. So, the degree of the differential equation is 3. Example 2. D square y by dx square equal to 1 plus dy by dx the whole square whole power 3 by 2. In this example, first we remove the radicals and fractions. Taking square root on both sides, we have d square y by dx square the whole square equal to 1 plus dy by dx the whole square whole power 3. So, here the highest differential coefficient is d square y by dx square and the power of the d square y by dx square is 2. So, the degree of a differential equation is 2. Next, we are going to study how to solve the equations of the first order and first degree by using the method of variable separable method. Suppose if a differential equation is of the form f1 of x dx plus f2 of y dy equal to 0, so that one term contains x and dx and the other term contains y and dy. Then the variables are said to be separated. Such an equation can be directly integrated. Suppose the given equation are not of the form f1 of x dx plus f2 of y dy equal to 0, we have to separate x and dx on one side and y and dy on another side. Then integrate on both sides, we get the solution. Hence the solution is integral of f1 of x dx plus integral of f2 of y dy equal to c, where c is a constant of integration. Next, we will see the problems by using variable separable method. Problem 1. Solve dy by dx plus square root of 1 minus y square by 1 minus x square equal to 0. Solution. First, write the given equation as dy by dx plus square root of 1 minus y square divided by square root of 1 minus x square equal to 0. Now, we have to solve the problem by using variable separable method. First, we separate the terms containing x and dx on one side and y and dy on another side. For this, we move the term root of 1 minus y square by root of 1 minus x square to the right hand side. We have dy by 1 minus dy by dx equal to minus square root of 1 minus y square by root of 1 minus x square. Then separate the terms y and dy on the left hand side and x and dx on the right hand side. We have dy by square root of 1 minus y square equal to minus dx by root of 1 minus x square, which implies dy by root of 1 minus y square plus dx by root of 1 minus x square equal to 0. Now we integrate on both sides. We get integral of dy by root of 1 minus y square plus integral of dx by root of 1 minus x square equal to c, where c is a constant of integration. We know that the differentiation formula of integral of dy by root of 1 minus x square equal to sine inverse of x. By using this formula, we get the next step, sine inverse of y plus sine inverse of x equal to c. So, this is the general solution of the given equation. So, in this problem, we have to solve by variable separable method. First, we have to separate the variables x and dx on left hand side and y and dy on the right hand side. Then integrate on both sides. We get the solution sine inverse of y plus sine inverse of x equal to c. Next, problem number 2. Solve y dx minus x dy plus 3x square y square e power x cube dx equal to 0. Write the given equation as y dx minus x dy plus 3x square y square into e power x cube dx equal to 0. First step is dividing by y square on both sides. We have y dx minus x dy by y square plus 3x square e power x cube dx equal to 0. We know that the formula d of, that is differentiation of u by v equal to v du minus u dv by v square. So, by using this formula, the first two term can be written as d of x by y plus the second term can be written as d of e power x cube equal to e power x cube into 3x square dx. So, we replace the second term by differentiation of e power x cube equal to 0. Now integrate on both sides. We get integral of d of x by y plus integral of d of e power x cube equal to c. Now integrate on both sides. We get x by y plus e power x cube equal to c, where c is the constant of integration. This is the general solution of the given equation. In this problem, first we divide y square on both sides and then by using the formula differentiation of u by v on the first term and the second term is replaced by d of e power x cube equal to 0. Then integrate on both sides. We get the solution x by y plus e power x cube equal to c. This is the general solution of the given differential equation. Problem 3. Solve x dy plus y dx plus 4 into square root of 1 minus x square y square into dx equal to 0. Solution: first we write the given equation x dy plus y dx plus 4 into square root of 1 minus x square y square dx equal to 0. The first two term will be replaced by d of xy because d of xy equal to x dy plus y dx. So we have d of xy plus 4 into square root of 1 minus x square y square dx equal to 0. Then the second term will be moved to the right hand side. So we get d of xy equal to minus 4 into square root of 1 minus x square y square dx. Now separate the terms containing xy and d of xy on left hand side and the terms containing x and dx on the right hand side. We have d of xy by root of 1 minus xy the whole square equal to minus 4 dx, which implies d of xy by root of 1 minus xy the whole square plus 4 dx equal to 0. Now we integrate on both sides. Integral of d of xy by square root of 1 minus xy the whole square plus 4 into integral of dx equal to c. Since we know that d of xy by root of 1 minus xy the whole square equal to sin inverse of x. So we have integral of d of xy by root of 1 minus xy whole square, which is going to be sin inverse of xy plus integral of dx equal to x. So plus 4 into x equal to c, where c is a constant of integration. So sin inverse of xy plus 4x equal to c is the general solution of the given differential equation. Next we are going to see the problem number 4. Solve 1 minus e power x secant square y dy plus 3 e power x tan y dx equal to 0. Solution: first we have to write the given equation 1 minus e power x secant square y dy plus 3 into e power x tan y dx equal to 0. First, dividing by 1 minus e power x tan y on both sides, we have 1 minus e power x secant square y divided by 1 minus e power x tan y into dy plus 3 e power x tan y divided by 1 minus e power x tan y dx equal to 0. Now we cancel 1 minus e power x in the first term and cancel tan y in the second term. We have secant square y by tan y dy plus 3 e power x by 1 minus e power x dx equal to 0. We know that differentiation of tan y equal to secant square y. So replace the in secant square y by differentiation of tan y by tan y plus 3 into e power x also replaced by differentiation of e power x, because differentiation of e power x equal to e power x into dx. So e power x into dx, that which term is replaced by d of e power x equal to 0. Now integrating on both sides, we get integral of d of tan y by tan y plus 3 into integral of differentiation of e power x by 1 minus e power x equal to c. We know that the integral of d of tan y by tan y equal to log tan y, and integral of d of e power x by 1 minus e power x is minus log 1 minus e power x. So substitute these values. Log tan y minus 3 log 1 minus e power x equal to log c, where c is a constant of integration. Next, we apply the power rule of logarithmic form. Log of tan y minus log of 1 minus e power x whole cube equal to log c. Then by applying the formula for log a minus log b equal to log a by b, which implies log of tan y by 1 minus e power x the whole cube equal to log c. Next, taking anti-log on both sides, we get tan y by 1 minus e power x the whole cube equal to c, which implies tan y equal to c into 1 minus e power x the whole cube. This is the general solution of the given differential equation. Next, we are going to see problem number 5. Solve dy by dx equal to e power x minus y plus x square e power minus y. Solution: first, write the given equation as dy by dx equal to e power x minus y plus x square e power minus y. Next step will be dy by dx equal to taking e power minus y as common. So e power minus y into e power x plus x square. Next, we have to separate the terms containing y and dy on the left hand side and x and dx on the right hand side. We have dy by e power minus y equal to e power x plus x square into dx. Now, integrating on both sides, we get integral of dy by e power minus y equal to integral of e power x dx plus integral of x square dx plus c, where c is a constant of integration. Next step, integration of e power y into dy equal to integral e power x dx plus integral x square dx plus c. Next, we know that integral of e power y is e power y and integral of e power x is e power x, and integral of x square dx is x cube by 3. Substituting these values, we get e power y equal to e power x plus x cube by 3 plus c, which implies e power y minus e power x minus x cube by 3 equal to c. This is the general solution of the given differential equation. So today we have to studied variable separable method. How to solve the differential equation by using variable separable method. Basically, there are two steps. First, we have to separate the terms containing x and dx on one side and y and dy on another side. Then we integrate on both sides, we get a solution. Thank you.